the probability that a person with a positive test actually has the disease. So positive predictive value is true positives by the total positives into 100. Positive predictive value increases with increasing prevalence and increasing population. So the higher the specificity also, the higher the positive predictive value. Example, you have a group of 100 patients who test positive for a test, and of the 80 there are true positives, which are 80, and 20 are false positives. So the positive predictive value is calculated as 80 by 100, which is 80%. Number needed to treat. This is the number of patients who need to receive a treatment in order that one additional person achieves the beneficial outcome. So NNT is calculated by 1 by ARR, which is absolute risk reduction. Absolute risk reduction is CER minus EER, which is control event rate minus the experimental event rate. So if the RRR is in percentage, like 80%, then NNT is 100 by that ARR. So 1.25 would be in this case, and we round it off to 1, and ideally the NNT should be 1. Lower the NNT, the greater the efficacy of the treatment. A 95% confidence interval should accompany an NNT. Similarly, NNH is the number needed to harm. Number needed to harm is 1 by the ARI, where ARI is the absolute risk increase. Odds ratio. This is the measure of strength of association between the exposure and the outcome. It is used in case control studies. It approximates relative risk. It's calculated by odds ratio is equal to A by B divided by C by D. So the formula is AD by BC. If the odds ratio is equal to 1, there is no association between exposure and disease. If the odds ratio is more than 1, increased odds of the disease. And if it's less than 1, it may be protective. Example, if the odds ratio is 3 times higher risk of getting the disease by the ones exposed. So we express it as 95% confidence interval. And if 95% confidence interval is on either side of 1, it is not statistically significant. If the p is less than 0.05 and the confidence interval excludes 1, it is statistically significant. Adjusted odds ratio is used in multivariate logistic regression, and it estimates an association of a factor with the outcome while adjusting for confounders. Steps in writing a research project. You identify a research problem and define the research question. And a good research question should satisfy the finer criteria, which is it should be feasible, interesting, novel, ethical, and relevant. A review of literature and identify knowledge gaps, formulate aims and objectives, frame a null hypothesis if applicable, prepare research methodology, specify the study design, the study cohort, inclusion-exclusion criteria, sample size calculation. Statistical analysis plan, you specify the significance level with an alpha equal to 0.05 in confidence intervals. Institutional Ethics Committee approval is needed along with informed consent. Then we conduct the research, you analyze the data and you interpret, and then you report and submit to a journal. These are the steps. The tests of statistical significance. They determine if the association found in the study are true or due to chance. So if we have to compare two independent groups, it's an unpaired t-test that we use. If you have to compare two paired groups, you use a Paired t-test. If we compare more than two independent groups, we use a one-way ANOVA. Compare more than two repeated measurements, it's a repeated measures ANOVA. The association between categorical variables, you do a chi-square test. Categorical data with small expected frequency, you do a Fisher exact test. Correlation of two continuous variables, you do a Pearson correlation. If the p-value is less than 0.05, you reject the null hypothesis at 5% significant interval. If the p is more than or equal to 0.05, you fail to reject the null hypothesis. Type 1 error is an alpha error. You reject a true null hypothesis, so you get false positives. Type 2 error is a beta error, which is failing to reject a null hypothesis, which is false. So you get a false negative. So the power of the study is calculated as 1 minus beta. Randomized controlled study is an experimental prospective study in which participants are randomly allocated to a control group, to study groups, and then they are followed up over a period of time. This is the gold standard study. Its essential features are, first of all, randomization, that is allocation by chance. Simple allocation, there is block allocation and stratified allocation. It balances the confounders. Allocation concealment, it prevents a selection bias. Example, a central randomization. Control group, this could receive the placebo or the standard treatment. And then there is follow-up and analysis. The advantages of an RCT allows direct calculation of the relative risk, absolute risk reduction, and the number needed to treat. It's a gold standard for therapeutic interventions and gives strong evidence for causal relationships. The limitations are, it is time-consuming, it's costly, and there is loss to follow-up always in many patients. The forest plot. We note that if there is an increased prevalence, then there is increased positive predictive value, but the negative predictive value reduces. The lower the incidence, the higher the negative predictive value, but the lower the positive predictive value. Forest plot. This is a graphical display which is used in a meta-analysis or a systematic review to show the effect estimates and confidence intervals of individual studies and the pooled overall effect. The components include individual studies on separate rows. Square represents the point estimate of each study. For example, you're studying the RR, relative risk, or the odds ratio, and the size of the square reflects the weight of the study. The horizontal line through the square represents the 95% confidence interval. The vertical line is a line of no effect. So RR or OR, it's 1, mean difference, it's 0. Diamond represents pooled effect estimate. The center is the pooled estimate and the width gives you the 95% confidence interval. Heterogeneity is reported as I square and Cochrane Q. Example, you take 3 studies, 1, 2, and 3, and the diamond represents the pooled data, and the horizontal lines of each represents a confidence interval. So if the line crosses the line of no effect, that is statistically not significant. The bigger the square and the smaller the confidence interval, which does not cross the vertical line, has more weightage. The diamond is the overall result of the meta-analysis. If it crosses the vertical line, it is not significant. Case control study versus cohort study. Case control is based on the disease or the outcome. Cohort is based on the exposure. Case control study, you start with the disease and then you look at the past exposure. But in cohort, you start with the exposure and you follow them up to see the outcome. Case control study, there are two groups, cases and controls. The groups in a cohort are the exposed and the unexposed. Case control study is retrospective, cohort is prospective. In a case control study, you determine odds ratio. Relative risk is what is determined in cohort. Case control study is for rare diseases, but this cohort study is for rare exposures. Case control is fast and cheap, but the cohort is costly and slow. Case control study can have a recall bias. Cohort study can have loss to follow-up. Relative risk is the incidence in the exposed divided by the incidence in the unexposed. Univariate versus multivariate analysis. A univariate analysis is a statistical analysis of a single variable at a time, mainly to describe its distribution and characteristics. Continuous variables are mean, median, and range. Categorical variables are proportion, percentage. Multivariate analysis, a statistical analysis which assesses multiple variables simultaneously in order to adjust for confounders. The methods used are multiple linear regression, multiple logistic regression, Cox proportional hazards regression. Example, univariate analysis, you study the association of ascites with mortality. But a multivariate association of ascites with mortality and in the presence of AKI, male sex, age more than 50, total bilirubin more than 4, other things can be, the confounders can also be accounted for. Student's t-test is a parametric statistical test to determine if the difference between two means is statistically significant. The types are one sample t-test, paired t-test, and unpaired t-test. One sample t-test, you compare means of one sample versus a known reference. Example, hemoglobin mean of a population studied versus the known reference, say 12 grams. Paired t-test compares two measurements on the same subjects or matched pairs. Example, BP in a group of 20 before and after taking amlodipine. Unpaired t-test compares two measurements of two separate groups. Example, you compare 20 people taking 20 people with HCC, 20 people without HCC, two groups that are not paired. Consort chart. This is a consolidated standards of reporting trials. It's a flow chart to describe the progress of participants through different stages of an RCT. So the patients are assessed for eligibility. You exclude them if they're not meeting the criteria. And the first step would be enrollment. The second step would be allocation. So allocated to an intervention, allocated to a control. Third step would be follow-up. And the fourth step would be the analysis. What is blinding? Blinding is a masking technique in a clinical trial in which one or more persons are unaware of the treatment that is allocated. So this is in order to reduce a bias. So there's single blind in which the participant is unaware, double blind in which the participant and the treating team is unaware, triple blind, the participating person, the treating team or the investigator, and the analyst are all unaware. The intention to treat versus per protocol. Intention to treat, say for 100 patients, 50 patients have drug A, 50 have drug B. In the middle of the trial, 20 on the drug A switch over to B. They are still analyzed as having taken the A drug. So it's based on the original allocation. It estimates the effectiveness. But a per protocol analysis, if they have switched, they are analyzed based on what they completed the trial with. This is more closely related to the actual adherence in the population. Cross-sectional study. This is an observational study in which exposure and outcome are assessed simultaneously at a particular point or a short period of time, and there is no follow-up in this. Example, 1,000 adults visiting a hospital are screened for obesity and MASLT. So the exposure at that time is obesity. Outcome is the MASLD, and they are assessed together. The advantages of this are it is easy, cost effective, there is no follow-up, and it measures the prevalence of the disease burden. It can assess multiple exposures or outcomes, but the disadvantages are it cannot measure incidence, it cannot establish a causality, it cannot establish a temporal relationship between the exposure and the outcome, and it's not good for rare diseases. Meta-analysis. A statistical technique that combines the result of two or more individual or independent studies addressing the same research question. So, a forest plot is made in which the square represents the effect estimate of that individual study. Horizontal line is 95% confidence interval. The size of the square is the study weight. Vertical line is the line of no effect. Diamond is the pooled effect. Heterogeneity is quantified as I square, which is 0 to 25% low heterogeneity, 25 to 50% moderate, 50 to 75% substantial, more than 75% is considerable. 95% confidence interval. This is the range around the study result that tells us how precise the study is. Example, average weight is 70 kg with 95% confidence interval 68 to 72. That means we are 95% confidence that the true average weight is lying between 68 and 72. The importance of confidence interval. If it's a narrow confidence interval, the result is more precise. If it's a wide confidence interval, the result is less precise. If the confidence interval in odds ratio or RR includes 1, it's not statistically significant. In difference between groups, if confidence interval includes 0, it is not statistically significant. The nested cohort study. A study within an existing larger cohort. So a cohort of 10,000 smokers is studied for 10 years to see if they develop lung cancer. Of these, 2,000 have genetic testing to see if it plays a role. So a smaller study nested within an original cohort is a nested cohort study. Funnel plot. This is a plot which is used in meta-analysis to look for publication bias. So each dot represents one study. The x-axis is the treatment effect, example odds ratio. Y-axis is the precision or the study size. Larger studies are closer to the top. Smaller studies will be spread widely at the bottom. How do we interpret it? There is symmetrical inverted funnel and an asymmetric funnel. Asymmetric funnel, the subject, this has a publication bias, but a symmetrical one, population bias is unlikely. And the symmetrical one looks like this. Asymmetric one, there's some part missing at the bottom. Measures of central tendency. Mean, average of the values, example 2, 4, 6, the mean is 4. This is affected by extreme values. So if you have 2, 4, 6 and 240, the average will be closer to 100. So that's affected by extreme values. Median is a middle value. So the values are arranged in ascending order and the median of 2, 4 and 50 will be 4. So it's preferred for skewed data. And the mode is the most frequently occurring value. So 2, 2, 4, 5, the mode will be 2. It's useful for categorical data. So for normally distributed data, we use a mean. For skewed data, we use median. And for categorical data, we use mode. Parametric versus non-parametric tests. Parametric tests are used for normally distributed continuous data. Non-parametric tests are used for data not normally distributed. Parametric tests are represented as mean plus or minus standard deviation. Non-parametric tests will be represented as median because it's skewed data. So examples are 2 independent groups. You use unpaired t-test for parametric, Mann-Whitney U-test for non-parametric. 2 paired groups. You use paired t-test for parametric and Wilcoxon signed rank test for non-parametric. More than 2 independent groups, you use one-way ANOVA for parametric, Kruskal-Wallis test for non-parametric. More than 2 repeated or paired measurements, use repeated measures ANOVA for parametric, Friedman test for non-parametric. correlation, you use Pearson correlation here, Spearman correlation there. Analysis of variance or ANOVA. It's a parametric test to compare the means of 3 or more groups. Example, we want to compare the weight loss with 3 drugs. Drug A 3 kg, B 5 kg and C 7 kg. So the ANOVA compares the variation between each group and within each group. It produces an F statistic. If the P is less than 0.05 and at least one group, it is statistically different. One-way ANOVA, one factor, example weight and drug loss are analyzed. Two-way ANOVA, 2 factors, example drug and sex on the weight loss are analyzed. Repeated measures ANOVA, same subjects are subjected at different points of time they are measured. Sukra plot, surface under cumulative ranking curve. This is used in network meta-analysis to rank multiple treatments from best to worst. Example, you compare 4 drugs A, B, C and D. The Sukra plot will tell you 90% effective treatment for A, 70% for B, C for 60%, D for 10%, and it ranks highest to lowest. What is a bias? A bias is a systematic error that causes the study result to differ from the true result. Selection bias is an error due to how the subjects are selected. Information bias or measurement bias gives you incorrect measurements. Recall bias, the cases remember the previous exposure better than the controls. Observer bias, observer's knowledge influences the outcome. Publication bias, the studies with a positive outcome are more likely to get published. That's a publication bias. Sensitivity, the ability of a test to correctly identify those with the disease. So, SNOUT, sensitive test, negative rules out the disease. Specificity is the ability of the test to identify correctly those who do not have the disease. SPIN, specific test positive, rules in the disease. So we display the chart as disease plus, disease minus, test plus, test minus. And sensitivity, you have to do true positive divided by the total number of disease into 100. Specificity is true negative divided by the total number of those who do not have the disease into 100.